members to another episode on AS your G12 exams. So in this episode we continue looking at the November 2022 Science Paper 1. In the previous episode we covered the question B3 extensively. Then remember that the first 4 episodes covered the multiple choice section. So let us look at question B4 extensively in this episode. Question A: two successive crests of approaching water waves are separated by a distance of 1.80 meters. It takes 0.3 seconds for one crest to cover the distance of 1.80 meters. Roman numeral 1 of M, at what speed is the wave traveling? So basically in this case the question is asking us to find the speed. So what are the few things that we know that we've been given? We know that we have two successive crests. So if you have a wave moving in this direction like that, then this is a crest and this is a crest. Then basically this distance between these two successive crests is known as the wave length. So this is what we know. So in this case we can tell that this is the wave length, which is 1.80 meters. Then it takes 0.3 seconds for one crest to cover the distance of 1.80 meters. To cover the wavelength is taking about these seconds. So this is basically the period. So the period in this case is equal to basically 0.3 seconds. Okay, that's the period. Then if we know the period and we know the wave length, we can easily find the speed of the wave. So there are two ways that we can find. Basically we can use this to find the frequency. So the frequency is 1 over the period. So in this case we have just basically 1 over 0.3 seconds as in the frequency. Then we know that basically velocity, which is the speed, so velocity is given by wavelength multiplied by frequency. So in this case it will just be 1.8 multiplied by 1 over 0.3, which is basically equal to 6 meters per second as in the velocity. Or alternatively we can use this formula, which is the speed is equal to distance over time. So in this case, what's the distance? So the distance being covered is this one over the period of that. So it will still be the same as basically 1.8 divided by 0.3, which will give us 6 meters per second. So basically 6 meters per second is the speed of this wave. Roman numeral 2 of M: what distance is covered by the wave in 2 minutes? So we are looking for the distance covered. Now if this is basically the formula for speed, then I can find distance by just multiplying by distance is equal to basically speed multiplied by time. So remember, just from finding speed, so it's important that you get question Roman numeral 1 correct. If you don't get it correct, then even Roman numeral 2 will be incorrect. So the speed there is basically 6 meters per second. Then this time should be in second. So these 2 minutes we need to convert it to a second, which will be basically 2 minutes. How many seconds are in a minute? Is 60. So we are multiplying by this 60. So once we do that, basically what we are going to discover is this will give us a second. So seconds and seconds cancels. So we're going to remain with 6 multiplied by 2 multiplied by basically 60, which is the same as basically if you simplify this one, which is this one, it will be 6 multiplied by 120. Use your calculator, we're going to find out that basically this is nothing but 720 meters as in the distance covered. Let us look at question B, Roman numeral 1. Calculate the frequency of sound wave with speed 340 meters per second and wavelength of 0.5 meters. So we have been given 2 critical things, and we know that basically velocity or the speed is equal to wavelength multiplied by frequency. So we've been given the speed, then we've been given the wavelength, we are asked to find the frequency. So what we do is to find frequency, we divide by this side wavelength, so that and that cancels. So frequency is equal to basically velocity over wavelength. So basically a frequency is equal to 340 meters per second, which is speed, divided by basically 0.5 meters. So when we use our calculator, it's the same as we have 340 multiplied by 1 over, or divided by 1 over 2, like that, which is the same as we are just multiplying it by 2. So basically when we use our calculator, we are going to find out this is basically going to be 680 S as the frequency. So this is 680 S. Then basically when you do that, you get this 1 mark. Then we look at Roman numeral 2 of beam. Could this sound with the frequency calculated in B Roman numeral 1 be heard? So the answer would be basically yes. So yes, this could be heard by human beings. Justify your answer to B Roman numeral 2. So human beings can detect sounds in the frequency. Remember the frequency range? We talked about this in section M. Frequency range from about 20 Hz to 20,000 Hz. Okay, so you notice that this 618 is falling within that range. So it's falling within this range, 20 Hz to basically 20 kilo Hz, which is the 20,000. So because it's within this range, it can be heard. If it was outside this range, it cannot be heard. So basically that's the logic behind. Please join me in the next episode as I look at question B5. Thank you viewers for watching this episode. If you find this video to be helpful, please consider liking, and also if you're new to this channel, consider subscribing. By liking, subscribing and sharing, you are going to help us improve our visibility. A simple like from you makes a big difference. So once you subscribe to our channel and go to our channel, we discover that we've got so much content. So we've got mathematics based revision questions, we've got physics, we've got chemistry, then we've got also topic based section for all the subjects. And this is the best section for you if you're having any challenges in any particular topic.